Hello and welcome to Deeksha Karnataka YouTube channel. So in our topic less than 30-minute series, today I am going to discuss another important topic, that is series and parallel combination of capacitors. This is a super important concept in KCET. There are a lot of questions came in 2026 as well as maybe there will be questions on 2027 as well. So this is very important topic that you have to prepare and have to remember. There are some certain nuances. Even though the topic is easy, you might feel that I will solve it, but in the exam hall pressure, if you are not purely focused, you will lose marks. So that's why please trust me, I will explain everything, and there you will, all of your doubts, all of your queries will be cleared quickly. So let's start. So core part of electrostatics unit, one of the most consistently tested chapter in KCET. Okay, almost entirely formula based. It is one of the fastest topics that master and score full marks in. Tested both as direct numericals as well as conceptual. Statement based MCQs do come from this chapter. Mixed series and parallel networks are favorite way of examiners to twist an easy formula. So they to test your knowledge, they might twist the formula. So that's why this chapter is very essential for you to prepare. Okay, so quick recap. Obviously, a capacitor is a device that stores electric charge and energy between two conducting plates separated by an insulator. Okay, so basically what is happening here, if you consider over here, basically whenever we talk about capacitors, it is 99.9% times it is actually parallel plate capacitor. So that means we have two parallel plates, okay, one having a charge, just a second. So one having a charge plus Q, another one having a charge minus Q. Okay, so here some insulating medium can be present between the capacitor plates. It can be air. Air is also an insulator. It can be a mica sheet. It can be a paper. It can be a waxed sheet as well. Wax acts as a insulator. So it can be anything that can be present between the plates. Okay, the capacitance formula is given by Q, C is equal to Q upon V. Its unit is farad, okay, or F. Okay, now here you can write farad with capital F. Why? Because Faraday is the name of the person. So normally we say that, for example, in many units we generally do not write the first letter capital. For example, for force we write Newton with small n, but for Farad you can do, because it is Michael Faraday is the name of the person. So the only part of that name is taken as farad as units of capacitor. So most of the units are actually taken from the name of the persons, right? So but in case of farad, it's not actual name of the person, so you can write as capital F as well. Small f is obviously okay. Now what is the formula for energy stored? Energy stored formula is half CV square or half Q into V as well as Q square by 2C. Okay, now for practical purposes, the farad unit is huge. Huge means huge. Okay, if you are considering a spherical capacitor, or just for example, not parallel plate capacitor, spherical plate capacitor is slightly different. Just for your understanding, if you want to develop a spherical capacitor which can store 1 farad of which has a capacitance 1 farad, the size of that sphere will be much bigger than that sphere or the size of the earth itself. So it will cover the entire earth to have 1 farad capacitance, just to give you an idea. So farad is a huge unit. It can be reduced to a smaller size for a parallel plate capacitor, but in that case also it will not be very small. Okay, it will be huge size for 1 farad capacitor. The capacitors that we use are actually of the order of nanofarad, picofarad, microfarad, okay, millifarad also. So these are the most commonly used units of capacitance. For all the questions you will see microfarad, picofarad, you will never see farad. Okay, coulomb is still you might see coulomb, 1 coulomb, 2 coulomb charge you might see, okay, even though that is a large number of electrons, but farad is really huge. So we do not use farad, but we mostly use picofarad, microfarad or nanofarad. Okay, Now series combination, what is the series combination? Very simple. There is only one and one path. Okay, the current can pass or charges can flow in only one direction. There is no alternate path available for the charges. So whatever charge is stored over here, suppose plus q over here, minus q over here, this minus q will induce a plus q over here and minus q on the other side. This will do a plus q over here and minus q over here. So charge of each capacitor will be same. Now if you forget, plus and minus, we say that for capacitors, but when it comes to the charge of a capacitor is denoted by q. Okay, total charge of a capacitor is 0 always. Total charge plus and minus becomes 0, but if the total word is not mentioned, charge of a capacitor, that is q only. Okay, we take the positive value, and if it is total charge, then it is 0. So be careful if the question is being asked like what is the total charge of a capacitor, it will be 0. Yes, and if it is the question asked what is the charge on the capacitor, q. Right, now capacitors are connected end to end, one after another, forming a single path for the charge. Charge q is the same on every capacitor in the combination. The total voltage splits across the capacitors are, suppose the voltage across this one is V1, voltage across this is V2, and voltage across this is V3. And if you connect them to across a certain voltage source, say V, and this side say grounded for simplicity, then the voltage V is given by V1 plus V2 plus V3. So you just need to add the individual voltages to get the correct total voltage. Okay, so when you are trying to calculate the equivalent capacitance, that comes out to be C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3 dot dot dot. Okay, for two capacitors, if there are only two capacitors are present, the equivalent capacitance becomes C1 C2 by C1 plus C2. You all know that, but one very important point, if the capacitors, all of them are identical, that means if all the capacitors have same capacitances, say C, okay, identical in identical capacitors of capacitance C. So identical means all of them are just like their twin brothers. They are all twin brothers. They have same size, same height, same looking, everything is same. That is called identical, right? So identical means they all are same, their values are same. Then their equivalent capacitance formula is very simple. It is take any one value, divide by the number of capacitors. Okay, so suppose there are 10 capacitors, each of them have say 2 microfarad, their equivalent capacitance will be 2 by 10 microfarad. Okay, so this is a shortcut method, and this is very, very handy in many problems you will see in future. Key rule, the equivalent capacitance in series is always similar than the, it is always smaller than the smallest individual capacitance in the combination. Okay, so this is very important. The capacitance, the equivalent capacitance decreases. Okay, equivalent capacitance decreases. So if you want to decrease the equivalent capacitance, you need to connect them in series combination, right? So the smaller the equivalent capacitance is smaller than the smallest value. If you add say 1 2 3 4 5 6 7 8 9 10 like capacitance, each value having 1 microfarad, 2 microfarad, 3 microfarad, 5 microfarad, like that. Okay, the total capacitance, equivalent capacitance of that combination will be smaller than 1. It will be smaller than 1, 0.5, 0.6, like that. So equivalent capacitance is always smaller than the smallest capacitance. This is just a point, but super important, super duper important, and this is also super duper important. Okay, now parallel combination. What is parallel combination? Parallel combination is like bridges the same two nodes. So basically you take one line over here, one line over here, and then you connect them one by one. That is called parallel combination. The voltage across each combination remains same. The voltage across each capacitor remains same. In series combination, charge remains same. In parallel combination, voltage remains same. Capacitors are connected between the same 2 points, so every capacitor sees the same voltage. Okay, so this is connected, they are all independent from each other. You can say, okay, this is seeing this voltage, this is also connected with this is also connected with this. So each and every capacitor is connected with the same point. Okay, now that is common line, right? Common line means there is nothing there. So each capacitor sees the same voltage. Voltages across each capacitors are same. Now, because voltage is same, charge can be different. So this is Q1, say this is Q2, this is Q3. Okay, charges are different, but voltages are same. Voltage V is same across each and every capacitor in the combination. Okay, total charge in the circuit is given by Q equals to Q1 plus Q2 plus Q3 and dot dot dot. Okay, now what is the equivalent capacitance formula? This is the easiest equivalent capacitance. For parallel combination of capacitors, the equivalent capacitance is C1 plus C2 plus C3. Now, one very important point here, many students confuse series combination of resistors and series combination of capacitance because they are actually opposite. In series combination of resistances, they gets added. In parallel combination of capacitances, they gets added. In parallel combination of resistors, they are reciprocally added. In series combination of capacitors, they are reciprocally added. So that creates a confusion because resistance we are familiar with from our lower classes, but capacitance we are starting new. So when we are solving, we ignore the capacitance term, we put the resistance formula and get a 0 mark. So do not do that. Make sure you understand capacitance, resistances are different. Their formulas are different, right? So n independent capacitors, n identical capacitors. So if in case of identical capacitors, it becomes multiplier. Take any one value and multiply with the total number of capacitors, you get the n equivalent capacitors. Total charge stored in a capacitor is basically C equivalent into V. This formula is valid for all cases, does not matter series or parallel. This will be always the same case. Key rule, the equivalent capacitance in parallel always greater than the greatest value of the components. So suppose you are connecting 1, 2, 3, 4, 5, 6, 7, 8, because they are getting added, okay, the value of equivalent will be bigger than the biggest value. That means if you want to increase the capacitance of a circuit, they are always connected in parallel combination. Okay, if you want to increase the capacitance of a circuit, they are always connected in parallel combination. What else? So series versus parallel at a glance, this is a table that will help you to remember entire series and parallel at one go. So charge, okay, same on every capacitor, divides amongst the capacitors. Okay, voltage divides among the capacitors, same across all capacitors. Okay, equivalent capacitance less than smallest c, so capacitance decreases, greater than largest c, so it is increases. Okay, so formula, it is basically 1 upon ci, it is sum of ci. Ci means any one, I can take 1, 2, 3, 4, 5, 6. So basically summation of ci means c1 plus c2 plus c3 plus c4. Here 1 by c equivalent is 1 by c1 plus 1 by c2 plus 1 by c3 dot dot dot. Okay, resistor analogy behaves like resistors in parallel and here behaves like resistors in series. So that is the major problem that you might have, that your head is lingering around parallel combination of resistances and parallel combination of capacitances. They are exactly opposite. So series combination of capacitor behaves like resistors in parallel. Okay, parallel combination of capacitors behaves like resistors in series. Okay, so that is what you need to put in your head if you are still struggling with these concepts. Okay, I have seen students, they are struggling because their mind is still at class 10th level, right? So that is one very important point, you have to overcome it. Okay, now shortcut formulas. If n identical capacitances are connected in series, equivalent capacitance becomes C upon n, and two capacitors are in series, it becomes C1 C2 by C1 plus C2. Okay, for identical in parallel, it becomes n into C. Okay, now In a series combination, the smallest capacitor dominates. Okay, C equivalent is pulled closer to the smallest value. In the parallel combination, the largest capacitor dominates the sum. So basically, if you add 100 say microfarad to some smaller values, the value will be bigger than 100 and it will be close. 100 will dominate the smaller ones. But in series combination, the smallest value, whoever is smallest, will say, oh, I am smallest, you cannot ignore me. You have to come closer to me. So the equivalent capacitance becomes smaller than that smallest value, right? That is also something important. Now some example, 3 capacitors of 2 microfarad, 3 microfarad and 6 microfarad are connected in series. Find the equivalent capacitance. So they are connected in series. So you cannot add them. You have to add them reciprocally. And another important point, C equivalent is equals to 1 by 2 plus 1 by 3 plus 1 by 6. So their LCM is 6. So here we get 3 2s are 6 plus 2 3s are 6 plus 6 1s are 6. So we get 6 by 6. So the equivalent capacitance will come out to be 1. Now here this is okay. If you saw after solving this, after solving it, you get a value say 1 by x. I have seen students after solving it, they write the correct answer is 1 by x. They forget to take the reciprocal on both sides. They forget to take the reciprocal on both sides. You should not make that mistake. Okay, when you are calculating series combination, you have to take reciprocal. Now here this is 1, reciprocal of 1 is also 1. Okay, so that does not matter. But here once you are doing the reciprocal, it should be, you need to do it in the both sides. So that is another important point. Okay, so the value is 1 microfarad. Okay, now let's move on. C1 is equal to 2 microfarad and C2 is equal to 2 microfarad are connected in series. This combination is connected parallel with C3 equals to 3 microfarad. Find the equivalent capacitance. So here we have 2 microfarads connected in series and their combination is connected in parallel with a 3 microfarad. So what is the equivalent capacitance? So they are basically equal capacitors, right? Identical, equal value. So what is the equivalent capacitance? Take any one value, divide by number of capacitors, that is 2. So you get their series combination is having a capacitance 1 microfarad, right? One step solution. You don't need to invest too much 1 by 2 plus 1 by 2. No, do not do that. It is simple one process. Take one value, divide by the number of capacitors, you get the equivalent capacitance. Now they are connected in parallel. So in parallel they gets added. So 1 plus 3 microfarad, that is 4 microfarad. Okay, so correct answer is 4 microfarad. Clear how to solve it? You can use the shortcut formula, other shortcut formula as well, but because they are equal value, you can directly calculate their equivalent capacitance. Now common mistakes that you need to avoid. Mixing up with quantity stays constant. Q is same in series, V is same in parallel. That is one concept. Solving series formula and forgetting to take the reciprocal of the final answer. So that's what I'm saying. You have done everything correctly, but you forget to take the reciprocal at the end. So after doing everything, you will get 0 marks because you forget to take the reciprocal at the end. Misreading the mixed network, wrongly grouping capacitors in series and parallel. So that is one problem. Okay, so if you sometimes it is the diagram can be given to you little bit confusing and you are not sure which one is connected in series, which one is connected in parallel, and you make mistakes there. Not converting microfarad, nanofarad and picofarad to the same unit before substituting. Some cases it might be applicable, especially if it is coming in a PU board exam. Maybe they will give you microfarad, nanofarad and picofarad mixture capacitances. You need to convert them accordingly. That is another important point. Okay, now series. So this is a cheat sheet for quick revision before your KCET exam. So C equivalent is this. C equivalent is this for parallel. Okay, charge remains same, voltage different, C equivalent is smaller than the smallest, same across each, charge Q divides, and C equivalent is larger than the largest. Okay, so this is the end of today's short revision session, because obviously every time you have to revise, every 7 days, every 14 days you have to revise the concepts that you have studied, and I am here, I will help you with the each and every chapter with less than 30-minute session. And if you watch this, your revision of the concepts will be done very, very quickly. And also mention in the comment section if you want any other topics to be reviewed quickly in this 30-minute segment, so that I can help you out with. Now, one very important thing, if you want to download this PDF or any other upcoming lecture PDFs, you have to go to our YouTube channel, click on the description section, and what you have to do, once you come, for example, I will show you the last 30-minute session that I have done in my in our channel. So here is the last 30-minute session, which is Wheatstone Bridge. You come over here, you click on the free ACE KCET 2027 course, which is also given in the description section of this video. Click over here and you will get the batch for absolutely free of cost. You don't need to pay anything. Click here, ACE KCET 2027 0. Click on buy now and you will be redirected to our homepage. But here you have to register for the first time using your mobile number and email ID and your names, the class that you study, the board that you study, etc. Once that is done, you will be redirected over here and you will get all the lectures that was done in our channel. Okay, quizzes and assignments will be added very, very soon. It is not yet added, but yes, it will be added. I think by tomorrow you will get the content of the latest quizzes. Also, you will get the class slides for each and every lecture. Okay, you can download the class lecture as you wish. Okay, so all the lectures that we are doing, in our channel will be available in the form of PDF if you join this page. Okay, this is our one and only page where you will get all the PDFs, all the lectures, everything. Right, you can watch the lecture in 2x speed. You can ask Ved some questions, right? Ved AI is also there. So that will be very, very helpful for all of your KCET and PUC preparation. And I hope that you will register as soon as possible. And obviously, if as I mentioned, mention in the comment section below what topic you want next. And obviously, subscribe to our channel and like this video. I will get the inspiration to make more such videos in future. Till then, bye.